Right, hello again, Year 12. It's been a while since the last video, so what I'm going to do here is basically go through the paper one that you had a look at last week. So, yeah, the big wind down to the end of term. We've got obviously the summer holiday to look forward to, but at this moment, in terms of your academic studies, it should be all about eyes on the prize, which is the university grade prediction exams, which are hopefully going to be in September. So that has to be the most important thing academically for you guys to be thinking about. Anyway, right. So I've given you this paper one. You've had a look through it. You've had a look at the mark scheme. Some of you have. A lot of you, I've not seen any evidence that you've actually marked it. And annotated it. So that needs to be done. Before you look at the paper two, you need to go through the mark scheme, mark your your attempt at paper one. I need you to look at the examiner report as well. You need to scrutinise both the mark scheme and the examiner's report, okay? Because these questions can be quite challenging, as you've seen. It's not as straightforward as we've maybe been expecting it to be. As we've been going through the topics in year 12. Right. So, yeah, it's all about application of knowledge. Okay. The more practice you have with that, the better you become. But it's all about knowing where you went wrong and how to go right in the future. It's as simple as that. So, let's have a little look at the first question. So, what I'm going to do, it's going to be a few videos. I'll do it in sections. This video, we'll look at the multiple choice. Okay, right. First thing about exams. The first rule about exams, there's many, but the first rule is you can do any question at any time in any order. It's as simple as that. Okay, a lot of people think, I've got to do the multiple choice, then I've got to go on to question 11, then I've got to do question 12. Not at all. All right. At the start of any exam, have a quick flick through and just kind of like scope the exam out. Have a little look at what could be a good place to start. Have a look at the easy questions first. Now, with the multiple choice, this is really important. Okay. The correct order is not to do the multiple choice first or not to do the multiple choice last. The correct way to approach the multiple choice is to go through the multiple choice and do the easy questions and move on and come back to questions that maybe take a bit more care. As you're probably hopefully aware now, multiple choice at A level, the questions can be quite challenging and quite time consuming. So some multiple choice questions in A level physics will be very easy, will be very straightforward, will be recall of knowledge even. Okay, but some will involve quite a complex calculation. So let's have a little look at the multiple choice in order. So here we go. First question. Right, it's internal resistance, the EMF and internal resistance of a cell. Right, we want an expression for lost volts. Now, if you remember, lost volts is how much the EMF goes down when a current is flowing in the circuit. So if you remember the equation is EMF. So that's the total energy per unit of charge supplied to the circuit. Now we have an energy drop, we have a voltage drop, potential drops rather, in two places. We have a potential drop across this, we have a potential drop across this. So there's going to be two expressions for potential drop. Remember, this is the energy gain, the potential drops are the energy loss. So we have, that's the voltage across the external resistor plus the voltage across the internal resistor. Now, the voltage across the internal resistor, we cannot measure that directly, but we can replace it. We can replace it, can't we, with the total current in the circuit multiplied by the internal resistance, IR. Okay? Now, all we need to do now is to take this fella over to the other side, and we get E minus VR equals IR. So this is the expression for lost volts. It's how much the EMF drops down by when we start passing a current in the circuit. So that's our expression for lost volts. So the answer is B. Okay, easy peasy. Now that one should be fairly straightforward. That should be taking you maybe about 30 seconds to a minute to complete. So I'd expect you all to have to crack that, no problem. Right, next question is a tricky one. Okay, took me a while to get this. All right, a student measures mass in grams of a small projectile and velocity in kilometers per hour. All right, and we're going to need to calculate the kinetic energy, but we want the kinetic energy in joules. So what are we going to do? What's the conversion factor to get our answer into energy in joules? So let's start with obviously the kinetic energy equation. So we've got kinetic energy is a half mv squared. Right, now velocity, what's that measured in? It's measured in kilometers per hour, but we need to convert it into meters per second. So what's the conversion factor from going from kilometers per hour to meters per second? We should remember, well, obviously kilometers to meters we divide by 1,000. Okay, sorry, kilometers to meters we times by 1,000. And hours to seconds we times by, well, 60 seconds in a minute and 60 minutes in an hour, so it's 3,600. Right, so the conversion factor is, okay, if we want our velocity in kilometers per hour to be converted to meters per second, we times by this conversion factor here. 1,000 over 3,600. So going back to our kinetic energy equation, this is what we need to do. So kinetic energy is a half m. Now we have velocity in kilometers per hour, so we need to multiply by our conversion factor. Okay, which means that the conversion factor is this fella squared, isn't it? Now, how many of you went, okay, that's the conversion factor. It has to be, the correct answer has to be B. I did it first, okay? However, what have we missed? We've missed the fact that mass is in grams. It needs to be converted to kilograms. So going back to the equation here, if we've got mass in grams and we want to convert to kilograms, we need to divide by 1,000. So our conversion factor is actually 1,000 over 3,600 squared multiplied by 1 over 1,000.